And I'll read it out, and I'd then just like to look at these two sentences that I've written on the board. I'm not sure how challenging the thoughts really were. This was in relation to our first session. Anyway, I guess the basic premise was that unless you understand a concept, then you can't really paraphrase it accurately, since you don't know what it means initially. So the first point is there that you wouldn't have someone paraphrase a statement because the person didn't understand the concept. Rewording doesn't necessarily give correct understanding. Also, and I guess the teacher has to be aware of this, a student may inadvertently paraphrase a sentence in a way that gives a different meaning and believe that the paraphrasing has led to a better understanding. So there are one or two points that are being presented there. One issue that all of us need to confront as teachers is, what do we mean by understanding? What does understanding mean? The two statements here relate to physics. Do I say that a Year 4 student learning about some ideas in science, or a Year 10 student learning about ideas in science, do I say the child doesn't understand them if they don't understand them in the way that a physicist would? Do I? So is it possible for a grade 4 child to have a grade 4 understanding of the concept and still be said to understand it? Okay, so that's one issue for us. We need to establish what we mean by understanding. And the grade 4 child's understanding, say, of gravity may be quite different from the Year 8 understanding of gravity, or the Year 10 understanding, or the understanding of the physics teacher. So when we talk about understanding, first of all, we need to be really clear. I'm sure we've all been in a situation where we've said to a group of kids, do you understand? And they've said yeah, and I've said, okay, tell me about it. And whoops, they find it hard. And so the next time I say, do you understand? Fewer kids nod sagely. Because I've said to them, if you say you understand, I'm going to want you to tell me what it means. Often in the first case, they nod because what they think of what you've just said is reasonable. They haven't had a chance to put it together in their minds or synthesize it, but it seemed reasonable. So yeah, they nodded. Yeah, they understood it. One thing we need to bear in mind is that understanding gradually grows. Understanding gradually grows. So when the teacher says, I guess the basic premise is, unless you understand a concept, you can't really paraphrase it. I think you can paraphrase things where you have a grade 4 understanding, or a grade 6 understanding, or a grade 8 understanding. So that's one area. Margaret?
Isn't also the process of paraphrasing part of getting to understand the concept?
Yes, it is.
I think that's what it is.
Yeah, because what you're doing, if understanding is linking ideas in your mind, then that's what paraphrasing is doing. Paraphrasing is linking with synonyms. So one issue that may well arise when you're working with your colleagues next year is, but hold on, particularly in secondary context, but hold on, they're not going to understand it. We need to clarify what we mean by understanding. What is understanding? And can we have a grade 2 understanding and a grade 4 understanding? If we look at these statements here, a block of ice left over at the end of a party, sublimed even in the cool of the evening. Let's say I was going to teach that to a group of children. How might I do it? My first approach to this would be to have the students actually make a picture of what was happening. Dry ice, for all intents and purposes, is like ordinary ice, except you see a lot of gas coming off it. It's solid carbon dioxide. If we want to make smoke at a concert, we get dry ice. So you can imagine what would happen. We've got our block of dry ice. It's on a big plate. When you come back the next day, what's happened? It's gone. Okay. It was there before you left, and it's gone. Has anyone come and taken it? So we can visualise what's happening. When we come back and look on the plate, what do we see? Actually, we don't see a liquid. We see nothing. So let's get straight. Let's visualise what's happening. We started off with a block of dry ice. It was solid. I could lift it. You can imagine yourself staggering with the block of dry ice and putting it down. You come back the next day, there's nothing. There's no liquid, no puddle, there's nothing. And you've got no skin on or whatever. Okay. What does sublime mean in that case? Okay, we can visualise. I can lead the group of children to see that what was a solid has now become a gas. If the door of the room was closed, I can draw a picture that showed here was the ice. An hour later, there's a bit of it over there. There's a bit of it over there. Look out your undersum. It's all through the room. The gas is spread throughout the room. And as one of our Year 10 students said, it's gone from a solid to a gas. What must that ice have been like to allow it to do that? If I put a lump of concrete there, I wouldn't come in the next day and have a little bit up in the air there and a little bit up in the air there and a little bit up in the air there. I've got a block of ice that's the same size and it's just as heavy as a concrete. What's the difference between the two? One?
Is it unstable?
One of them was unstable. If it was unstable, and let's say you were inside the block of dry ice, how would being inside the block of dry ice be different from being inside the block of concrete? Let's say you were a little bit of concrete and you had a buddy who was a little bit of dry ice. What's the difference between them? What makes them unstable? Well, the temperature. There's some temperature. But what's happening? What must it be like for the little bit of dry ice in comparison with a little bit of concrete? Sorry, sir? One's disappearing. Why is it disappearing? It could be. Temperature's got something to do with it. But why is it? What does it mean about what it's like inside the two blocks?
The concrete's not moving and the other one is.
The concrete is not?
It's not moving, it's there, it's solid. Whereas the other one's in a process of moving and changing.
For it to be solid, what's making it solid? The materials. And what are the materials doing? They're holding. Things are holding. What is not in the dry ice?